Hi everyone, welcome to Vishwablooms. In this video, we'll be discussing alkanes. We'll be discussing the physical properties in this video. First, C1 to C4 are gases and neopentane is also a gas. But N-pentane and isopentane, they are low boiling point liquids. Okay, that is very important theory points. First, we are covering them. Then C5 to C17 are colorless liquids, whereas above C17 you find all of them are waxy solids. Now let us look at the next property, that is density. So density of alkanes is directly proportional to molecular weight. This implies that if the molecular weight of an alkene is higher, then its density is also be supposed to be higher. Generally it becomes constant at 0.8 gram per milliliter, and remember one point, all alkanes are always lighter than water. Now let us understand the solubility of alkanes. See, alkanes are generally, they are non-polar in nature, so thus they are insoluble in water, but they are soluble in non-polar solvents. Solubility is inversely proportional to the molecular mass. That means higher the molecular mass, lower will be its solubility. So for higher solubility we need lower molecular mass. So as discussed, it is insoluble in water, but it is soluble in non-polar solvents. So these are the examples for the non-polar solvents, that is benzene C6H6, CCl4 and ether. So these are some of the examples of non-polar solvents. And liquid alkanes are themselves good non-polar solvents. Now let us see the next physical property, that is boiling point. Now first we will discuss it for N alkanes, that is they are in straight change in this way. Suppose ethane, then CH3, CH3. So in this way, first we are going to see for straight chain. So boiling point is directly proportional to the molecular weight, and it is also directly proportional to the van der Waals forces of attraction, and that is directly proportional to the surface area. So if the van der Waals forces of attraction are higher, then you can see higher boiling point, and if the molecular weight is also higher, then you can see boiling points are higher, and for larger surface area you can see boiling points are higher. Now let us understand a simple example first. Here we have pentane, hexane and heptane. So we'll try to write the structures as we are discussing for N alkanes. I am going to write it in this chain form. So this is for 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. This is the structure of pentane. 1, 2, 3, 4, 5, 6. The structure for hexane, and 1, 2, 3, 4, 5, 6, 7. This is structure for heptane. So as the molecular weight is increased, so you can see as the molecular weight is increasing, the boiling point also increases. So heptane has highest boiling point in these examples. Now let us try to understand the boiling point in branching or branched chains. Suppose here we are taking N-pentane, isopentane and neopentane. Let us try to analyze the boiling point order for these three compounds. Firstly, we should understand that boiling point is inversely proportional to the number of side chain. That means as the area gets decreased, you see that boiling point also get decreased, right? See, as the number of side chain increases, the surface area is going to decrease. Surface area will decrease, and because of this, the shape will almost appear to spherical shape. It is approaching to spherical shape, so that it will decrease the van der Waals forces. That is why you can see that it is an inverse proportion. Okay. Now first consider this example. Here all are containing 5 carbon atoms. First we are seeing N-pentane, isopentane and neopentane. I have drawn the structures here. So N-pentane is a straight chain. See 1, 2, 3, 4, 5. 5 carbons are here. Here also 1, 2, 3, 4, 5 and 1, 2, 3, 4, 5. See, you can see that side chain branches are increasing. In n-pentane there is no side chain branching, whereas in isopentane you can see one side chain, and in neopentane you can see many of them, right? So as the side chains are increased, the boiling point is decreased. So here neopentane has the least boiling point, whereas n-pentane has highest boiling point. Now we have seen density, solubility and boiling point of alkanes. These followed some regular trend, but coming to melting point, it does not follow a regular trend. It has an irregular trend. So let us try to understand this trend as well. So for the melting point of alkane having even number of carbon atoms is greater than the melting point of alkane having odd number of carbon atoms. So this is the trend, okay? So let us understand why this trend generally, why we are able to see this abnormal trend. By using an example, let's understand this. So here I have taken an example containing 6 carbon atom, which is an even number, and here I have taken 5 carbon atom, which is an odd number, okay? So here you can see for odd number you have carbons on same side. For even you can see the carbon atoms, the terminal carbon atoms are present on opposite sides. So here packing is very close, right? So that is why melting point of this is higher than that of this, okay? So these were some of the important physical properties of the alkanes. In the next video we'll be seeing preparations and chemical properties. So thanks for watching our do like, share and subscribe to Vishwablooms. Bye.